antimicrobial resistance antimicrobial resistance panel. Do you have our sound?
Yes, doctor, we can hear you.
I can start, yes? First of all, I would like to thank from the Dr. Feizabadi, the head of Microbiology Society, and Dr. Abdullahi for this virtual webinar, and all scientific committee. And also, I would like to thank from all participants, colleagues, students, and all. And at the first time in this panel, we have 5 speakers, and I would like to thank from all of them that invite our invitation. The first speaker is Professor Christian Giske. It's our pleasure, our honor that we have Professor Giske in this panel. Dr. Giske is the chair of UCAS and research group leader of antimicrobial resistance. He has won some award, and he has several international projects. Thank you very much, Professor Giske, and you can start your speech. Thanks.
Thank you very much for the nice introduction. I've been tasked to talk about gram-negative pathogens and COVID-19 infections in relation also to the AMR problem. So largely this will be focused on the respiratory tract, since this is the main source of secondary infections in this population of patients. So let's see. So the scope of today's presentation is to overview the diagnostics of bacterial pneumonia, which is key for being able to identify the burden of this problem, and also describe some of the complexities and challenges of pneumonia diagnostics in general. What is pneumonia? What is colonization of the respiratory tract, etc. And also commenting on etiologies that are observed in COVID-19 patients, and finally the issues concerning AMR in COVID-19 patients. So first of all, let's discuss briefly about the selection of sample material. One of the convenient types of sputum in a non-intubated, non-ventilated patient is a sputum sample. The problem of it being that it's always contaminated with the oral microbiome, and also it needs to be quantitative. It needs to be assessments of the quality of the specimen by looking at the relation between epithelial cells and neutrophils. Also, there are methods for induction of sputum, and you can also wash sputum if you like to remove oral microbiome. If sputum sampling is done correctly, you can have a fairly good sensitivity and specificity if you go by quantitative criteria. So it's not a bad method, but of course in a ventilated patient, this is not an option. In a ventilated patient, you could use, however, for instance, the protected specimen brush. In the best form, you will use a bronchoscope, a flexible bronchoscope, to guide where you take the sampling. But in some cases, you can also do this through the tube of a ventilated patient. And this procedure ends with cutting off the catheter and sending it in nutrient broth. And there is a very high sensitivity and specificity of this analysis if it's done in a correct way. Then we also have bronchoalveolar lavage, and this can also be done in ventilated patients by not using the classical amount that you use for in the classical type of BAL, but rather low volume BAL, which you can also do through the tube and aspirate and get maybe then less than 10 milliliter yield. And again, we can see that this is a good method with fairly high sensitivity and specificity for diagnosing pneumonia. with, again, a quantitative cutoff value for determining. Finally, there's also the endotracheal aspirates, which is very important to standardize properly. If it is well standardized, it can have a fairly good performance also. But sometimes there are lots of variation of this, and quantification might be difficult because the sampling techniques might be different. In general, with quantitative cultures, there is for BAL a cutoff for significance of 10 to the 4 CFU per ml. For low volume BAL, it's slightly 1 dilution step lower. For protected specimen brush, it's 10 to the 3. And for endotracheal aspirates and sputum, it's 10 to the 5th to 10 to the 6th. If it's lower than that, it's also possible that you could have significance, but then it's less certain and higher risk for lower specificity. Some of the limitations of quantification are reviewed here. Some bacteria are always considered relevant regardless of the quantity. If you have treatment given before, antimicrobial treatment given before the sampling, that can affect the quantification. If you do sampling early in the course of infection, you can have inconsistent results. And also the same is true if you take multiple samples with the same technique, that it can vary within a long segment. So all of these problems are present, but still quantification is the best way to go to ensure that you have a fairly decent specificity and do not overestimate that the presence of gram-negative bacteria, for instance, in the lungs, is related to a true pneumonia and not to a colonization. So with regards to the invasive sampling, both in COVID patients and in others, yes, there is limited support that sampling is improving mortality, but there is a support for sampling decreasing the overall antimicrobial exposure, which is incredibly important in COVID-19 patients, because early in the days of COVID-19, there was such overprescription of antimicrobials, and this has led to some of the problems we see today. And indeed, sampling should not delay therapy, and it's a good way of guiding therapy. And I think there are different practices in different countries, but if you have no sampling, it means you also will have no information about your local situation. And of course, sampling in COVID-19 should be done with safety of the sampler, so that there are no biorisks there. But in general, this is a strongly recommended way of going about to ensure that you have data to guide whatever happens with your COVID-19 patients. So looking more into then the etiology of hospital-acquired pneumonia, we know that there are some bacteria that almost always occur in the samples and should be regarded as colonizers. Those are enterococci, coagulase-negative staphylococci, and candida species. There are no pneumonia-causing agents. And then there are some that are more or less regarded normal respiratory microbiota, such as the Streptococcus mitis group, although it can play a role sometimes in aspiration pneumonia. There are also some pathogens like Streptococcus pseudopneumonia, Haemophilus parainfluenzae, Corynebacterium pseudodiphtheriticum, and all of these may be under certain circumstances act as pathogens, but most of the time they should be regarded as respiratory microbiota. And if they are found in a mixed culture, they have very limited significance. And this is also why we need to be a little bit restrictive about what we call pneumonia pathogen. I think we quite simply also need to remember about Koch's postulates, that you should actually be able also in an animal to reproduce the pattern of pneumonia. And for many of these, such data is lacking, that you can have a picture of pneumonia in an animal model. Looking more into the etiology of hospital-acquired pneumonia, these are some data from Sweden, from a couple of places. We can see that Pseudomonas and Haemophilus influenzae and E. coli comprise an important part of it, but there are also some other gram-positives and some other members of Enterobacterialis that can cause a certain amount of the infections. In general, after short time with ventilation or in hospital, the community pathogens are more likely to be seen, and after a longer time, there is more likely to be more gram-negatives overall that are not known to cause acute infections in community acquired pneumonia. Some international studies with HAP and VAP report on something like maybe 1/3 of Enterobacterialis, 1/3 of non-fermenters, and maybe 1/3 of gram-positive cocci. But there is some variation with time and geographical location. Still, in the order of this is what can be expected, but in some places it might be slightly skewed with the balance of this kind of pathogens. In terms of what can be seen here in different types, healthcare associated pneumonia, hospital-acquired pneumonia, and VAP, the difference are not really that great. We have most data from VAP since it's easiest to do sampling in these. But the differences are not very substantial, and it's more or less common to try to extrapolate from between these different conditions. Sorry. We also know that there are some risk factors for resistant pathogens, and for instance, prior and intravenous antibiotic use, which is frequently the case in case of patients with COVID-19, particularly in the first days of the pandemic. There are also some meta-analysis that have been carried out in COVID-19 patients, looking at 30 studies of more than 3,800 patients, and looking at the pooled proportion of hospitalized COVID-19 patients, and finding bacterial co-infections in 7% overall, and in the ICU patients in 14%. So that's what is generally known from larger studies where we have tried compiling data to look into the burden of gram-negative of all co-infections. In COVID-19 patients from the same paper, it's known that it's surprisingly high Mycoplasma pneumonia, which is also maybe due to could be down to some particular situations in some places with co-infections. But if you look aside from Mycoplasma pneumonia, we have a number of gram-negatives that occur here. The proportion here being approximately equal for Pseudomonas, Haemophilus influenzae, Klebsiella, and also we have Enterobacter and some others. And some of them are unlikely to present as pathogen in this context. We have done some work ourselves with this population, looking also at molecular testing to see if we could find a greater yield. So these were the sample types we included. 83 sample types, 83 samples of these types from 68 COVID-19 subjects with a mean age of 58.8 years, and the majority being from males, and we used quantitative culture as a reference. And in our material, which was from the first wave of COVID, which was pretty strong in Sweden, we could see a high sensitivity and specificity. We did find some more with the molecular, but not extremely huge differences. And we found a predominance of Staph aureus in these samples, but we also found E. coli, Klebsiellas of different types, And then in our particular situation, Acinetobacter, Stenotropomonas, Pseudomonas were very rare pathogens, although it was a fairly low sample that we looked at. There are also some reviews that have looked into the particular issue, not only of what kind of gram-negatives we found, but also about specifically MDRs. And this, for instance, is one of the papers looking into this, where they have found some case control studies, retrospective observational studies, case series, which have reported on a number of MDR co-infections, and also on which microorganisms were observed, the number of deaths. And in general, the majority were reports on ESBL and carbapenemases. It was associated with high antimicrobial usage, despite, as we saw, a low frequency of bacterial infections in those studies that have looked at that. And the recommendation overall is increased focus on stewardship and avoiding antimicrobials to all patients, which might improve the situation. And in order to do that, we need to go back also to look at actual sampling of the patients. Of course, we can do blood cultures, which is fairly easy, but we also need to look at respiratory cultures. And this is what has been, at least in the early days of COVID, there was not so much sampling going on, and many patients got unnecessarily high amounts of antimicrobials. So if we zoom in a little bit more on some of these reports, there is, for instance, a report on MDR outbreaks in ICUs in Maryland, and it shows that what they detected was Acinetobacter, multi-resistant Pseudomonas, and also E. coli. And they could also follow different kinds of interventions, where they first started double occupancy, and then they ended it, and they started with more intensive infection control measures, and they managed to see a decline in the number of episodes, while the total surveillance cultures that we used remained high during this time. So in general, the risk factors were found to be critical illness, high antibiotic use, and the double occupancy of single rooms, and also modified infection prevention practices. And in general, again, surveillance culturing aided in outbreak recognition and control. And this is why sampling is really key for this. Instead of assuming that there is a high number of infected, we need to actually have samples to be able to carry this out. Hence the focus at the initial stage in my presentation on sampling for respiratory tract, which I think is a very important key to all of this. In a fairly recently published paper by David Livermore, there was a speculation in different AMR scenarios, which depend on what would happen in general with the pandemic, either if the vaccine is overwhelmingly successful, if it's perceived as a failure, or if there is a failure which is down to more or less the acceptance that the virus is established, it's endemic, that lockdowns are ineffective, or causing unacceptable collateral damage. And maybe this is not a very unlikely scenario. The more optimistic would, of course, maybe focus on maybe scenario A. But this has different implications. We can look into different kinds of compartments, so the community, where vaccine failure of the last kind would lead to a push towards more treatment and more resistance. And there would be also, if the vaccine is successful, there will be a backlog in hospitals due to many patients not having received care. They will be back in the hospitals, they will have infections, and that can also lead to more antimicrobial treatment and more situations with risk for AMR. But this could also happen if it's if it's a perceived failure, but not with a prolonged focus on track and trace. Finally, this will also have some implications on traveling, depending on whether we go for a continued restrictive strategy or whether we go for increasing traveling again, down to either the vaccine being successful or acceptance that we have failed to contain it properly, and that we would like to move ahead and accept the situation regardless of if we haven't managed to truly contain the virus. It's an interesting paper with a lot of speculations on what could happen, and it's clearly very difficult to know which one of these are the most likely, and maybe the answer is also that there will be different answers in different parts of the world as well. In summary of all of this, I would focus on distinguishing between COVID ICU patients with bacterial superinfection early, and being able to specifically tailor treatment and antimicrobial stewardship to this group of patients. But sampling is really key to be able to do that, and sometimes also surveillance cultures to be able to detect if you have ongoing outbreaks that require certain specific measures. There is also the different aspects of standardization of respiratory diagnostics that I discussed. There is an increased risk for outbreaks and escalating AMR if no stewardship efforts are carried out. And the future is quite unpredictable because it largely depends on how the epidemic is managed in various global regions, and to which extent the vaccine is taken and is effective. So all of that could contribute to deciding the outcome of this. And I think with that, I would like to end the presentation and open for questions or comments if there are any. Maybe there is also something already in the chat. I was unable to monitor that. Thank you very much.
Thank you very much, Dr. Giske, for nice presentation. And I have a question, Doctor. You told that about the future of antimicrobial resistance after COVID-19-15 is not known until this time. But some scientists warning about the next crisis and next pandemic may be antimicrobial resistance. What's your opinion and what's your suggestion?
Yes, no, I think it's already clear, and that was also prior to COVID. We had such situations in many parts. It's just that it's affecting maybe a different group of patients to some extent. So I think the AMR problem is, of course, you could say COVID-19 was also largely killing people who were slightly older or had comorbidities, but COVID-19 also killed fairly young people who had limited comorbidities, maybe just some minor comorbidities that also fell ill to it and died. I think people are more scared in general if there is more of a direct infection going on that will act in this way and might also be very dangerous for people who are, for instance, not hospitalized to start with. The problem with the AMR problem is that people do not realize maybe that it can affect themselves and their closest relatives and families whenever they need procedures that put them at risk of having AMR infections. But in general, if you belong to, let's say, a fairly healthy part of the community, then you are maybe not as much at risk of becoming an AMR case. So I think it's largely it's not about the numbers really, or about it's just that we see things as a threat to a very different degree depending on how much we feel that this concerns us. But certainly the endemic problems of AMR has not disappeared, will continue, might increase, will kill lots and lots of people, but I'm sure it will still not get as much attention as the pandemic, because the pandemic is more seen as a more acute threat, and it also, to some extent, is more unpredictable. But AMR is surely going to kill lots of people, probably much more than COVID-19, if we follow it in a longer perspective. I think there is a raised hand. Yeah.
Yeah, sorry, Dr. Shahcheraghi, Dr. Amini has raised his hand. If you get me, I'm gonna give him
yes, please ask your question.
Yes, Dr. Amini, please unmute yourself. You can ask your question.
Yeah. Sir, thank you very much for your gorgeous presentation. I had a question regarding the age group of the patients who are involved with this infection. The strain of bacteria which we are isolating from the patient, is there any significant correlation between the age group and the type of and strain of the bacteria which we are isolating? Thank you very much.
Yes, thank you for that. That's a good question. No, I don't think this is something we have consistently seen. Rather, I think it's more a factor of how long the patients have been hospitalized and been on a ventilator. So there is a very strong correlation with the number of days on the ventilator and the risk for gram-negative infection. But I think it could happen to anyone who is on a ventilator. To some extent, that in itself, the risk of ventilator is maybe higher in male sex, for instance, and also in older patients or the more comorbidities you have. But the greatest risk factor of this is the number of days in ventilation or in ICUs. So there is no clear correlation as far as I've seen that is more important than that.
Thank you very much, sir.
Thank you.
Seems that Dr. Shahcheraghi has got disconnected. We are waiting for her to come back.
I can see one question in the chat. What are your recommendations for sampling methods? And I think if you have a ventilated patient, I would try to go, for instance, with the brush sampling. Whereas if you have a non-ventilated patient, you could, for instance, try to go with a high quality sputum sample. And of course, bronchoscopic samples are always the best from the technical point of view, but they're also difficult to obtain.
The other question?
No, there is no question in the chat box.
Thank you very much, Dr. Giske, from your presentation. Thanks.
Thank you very much.
Thanks. The other speaker is Dr. Saleh. I don't know, Dr. Saleh is
presenter. Speaker میشه بلندگو.
Excuse me, Dr.
No, we
Saleh.
do not have Dr. Salehi.
I should call him. Dr. Salehi. Dr. Salehi is infectious specialist in Imam Khomeini Hospital, and he is engaged in COVID-19 vaccine. He is very busy, and he should come from hospital to his room for his speech, but I don't know why he cannot connect. خانم مهندس، من میتونم نفر بعدی رو معرفی کنم؟
بله خانم دکتر.
من میتونم نفر بعدی رو معرفی کنم؟
بله حتما.
اگه دکتر نصیری الان هستن و دکتر نصیری رو درست کنم.
Hello.
Hello, Dr. Nasiri, please go ahead.
دکتر نصیری.
Hello, everyone. Just a minute to let me just upload my slides, please.
Thank you very much.
Yes,
Because
please share your screen. Yes, we can see your screen, your slides.
Please share screen.
Yes.
We can see. Please go ahead.
Okay, thank you. Hello, everyone. First of all, I want to thank a special thank to Professor Fereshteh and Professor Abdullahi for their effort and the efforts of support team. This is Mohamad Javad Nasiri, PhD and PH Assistant Professor in Clinical Microbiology from Shahid Beheshti University of Medical Sciences. And please accept my apologize because my webcam doesn't work, and you can just hear my voice. My topic is about the co-infection of MDR, TB, and COVID-19. One of the important issues in the field of infection diseases is the simultaneous infection with drug resistance, tuberculosis, and COVID-19. And I will talk about this. Am I in the next slide or no?
Yes,
we can see your slides. Yes.
And would you please full screen?
No, Dr. Shahcheraghi, there is no such possibility for him. Dr. Nasiri, we can see your second slide.
Oh, you can see. Thank you. Okay. In this slide, you can see the topics that I will address in this presentation. First of all, I will talk about the review of global TB and COVID-19 epidemiology and their comorbidity and co-infection. And at last, I will little talk about how to manage a patient with these both infections. In this map, you will see that this rate associated with MDR-TB, which in most African countries is more than 20 cases per 100,000 people. As you can see, the red country, the death rate are more than 20 cases per 100. What? In the next slide, Dr. Shahcheraghi, I didn't understand what you were talking about. You was talking about. Okay, I will continue. In this slide, TB, as you know, TB became the leading cause of the death from infectious diseases worldwide in 2019, when it suppressed HIV infection. However, on April 2022, COVID-19 suppressed TB in the term of number of deaths. This map is related to the deaths in confirmed cases of COVID-19. As you can see, in some countries, the daily mortality rate is very high, as our country, Iran. As figures show, TB has a higher mortality at the population level in much sub-Saharan African country than COVID-19 in Europe and the US. In our meta-analysis study that was published in Frontier in Medicine and now is used as a COVID guideline in the UK, in the meta-analysis, we found that the number of reported deaths from the COVID-19 was higher than that reported. Based on our analysis, this rate was estimated to be more than 6%. In this slide, I don't know it's you can see the my publication or not. In this slide, I want to talk about the risk factor and comorbid disease can increase the severity of the disease and mortality in patients with MDR, TB, and COVID-19 co-infection. In a study that we published in a reputable journal, we showed that age, gender, cardiac disorder, diabetes, and kidney diseases are among the important risk factors that can increase the severity of COVID-19 disease. According to the result of our study and other study, there are common risk factors and underlying diseases that can increase the severity of both TB and COVID-19 diseases and consequently increase the mortality rate. Therefore, these factors should be considered in both diseases. Due to the importance of the mentioned issue, there is limited information about the MDR, TB, and COVID-19 co-infections. Due to the lack of any summary of conditions, a systematic review and meta-analysis to clarify the characteristics and outcome of these diseases was conducted. As any systematic review, several databases such as PubMed, Medline, and Embase were used to retrieve relevant articles. All studies describing patients' co-infection by MDR, TB, and COVID-19 were selected. We chose only patients with confirmed MDR, TB with a standard drug susceptibility testing and those with confirmed COVID by molecular test. In our inclusion criteria, we used a new definition of peri-XDR-TB and revised the definition of XDR-TB by the WHO. As reported in a new definition, MDR-TB, reported in a new definition, peri-XDR-TB are those caused by mycobacterium tuberculosis strain that fulfill the definition of MDR-TB and at least resistant to any fluoroquinolone. Furthermore, XDR-TB are those that caused by mycobacterium tuberculosis strains that fulfill the definition of MDR and that are also resistant to any fluoroquinolone and last and at least one additional drug in group A. As you can see in this slide, WHO updated guideline indicated that...
Sorry, Dr. Nasiri, we only see your slide related to the TB and COVID-19 morbidity.
I'm now in.
You are not on the correct slide.
Sorry. I'm now in slide 11.
Yes, now we can see it.
Okay, thank you for your attention. And in this slide, you can see the updated WHO guidelines on drug resistance tuberculosis treatment. As you can see in group A, there are levofloxacin, moxifloxacin, bedaquiline, and linezolid. We use this guideline for inclusion criteria. But the main finding, 115 cases of TB and COVID-19 co-infection were identified from retrieval studies, of which 9 cases, 10%, fulfilled the criteria of co-infections. The result highlighted that co-infection with difficult-to-treat pathogens, such as MDR-TB and SARS-CoV-19 can occur. COVID-19 and MDR-TB could present significant challenges in screening, management, and infection control. Now I want to speak how to manage MDR-TB and COVID-19 co-infection. Considering the screening, the important point is that any patient who has symptoms of TB should be tested simultaneously for MDR-TB and COVID-19. As you know, the GenExpert device, as the picture is shown in the slide, is now used in many countries to diagnose MDR-TB. Recently, the Cepheid company, the manufacturer of the GenExpert device, has introduced the cartridge of this device to market for the diagnosis of COVID-19 disease. So we can use this device to diagnose patients with both MDR-TB and COVID-19. In the discussion, in the regarding of the treatment, it should also be noted that COVID-19 poses a serious threat to successful anti-MDR-TB drugs. The WHO recommends MDR-TB regimens to include bedaquiline, linezolid, fluoroquine with addition of clofazimine and cycloserine to achieve at least 4 effective drugs. But this medication carry potential adverse side effects that may exacerbated by the symptoms associated with COVID-19. Those patients with COVID-19 can present with elevated liver function enzymes, which may prevent the use of bedaquiline, a drug known for being hepatotoxic. The use of linezolid, another core drug in MDR-TB regimens, is also associated with bone marrow toxicity. Therefore, to ensure that patients with both diseases should effectively managed and their laboratory and their lymphopenia, transaminitis, and erythematitis should be checked before the treatment are started. And MDR and multi-drug resistance TB medication may need to be held if such abnormality occur. In the field of prevention and infection control, the use of BCG vaccine is very challenging, and the results are controversial. In addition to the specific effects of the BCG vaccine, its not specific effects have also been proven in a number of articles. For example, as you can see in this picture, an article that published in 2016 in the Journal of Clinical Infectious Diseases, the authors showed that the BCG vaccine can prevent respiratory infection and sepsis in the children. But other non-specific effect of BCG vaccine can be shown against COVID-19. According to the one study, the mean of deaths per population ratio was found to be significantly lower in a BCG vaccinated country compared to those that are not vaccinated. However, another study showed that there was no differences. There was no difference between vaccinated and unvaccinated people. Based on our unpublished meta-analysis study that is currently under review, we indicated that hospitalization was found to be lower in BCG vaccinated than those not vaccinated. Another important issue in the topic of infection control is that the nosocomial spread of COVID-19 among TB patients has already been documented and highlights the vulnerability of MDR-TB hospitals to this pandemic. Thus, patients with MDR-TB must be screened for COVID-19 before hospitalization to prevent nosocomial transmission among patients with MDR-TB as well as healthcare workers caring for them. In conclusion, we have to know that COVID-19 pandemic may adversely affect the care of patients with MDR-TB. It's imperative to design a triage pathway to detect MDR-TB, to monitor co-infected patients for rapid decline and drug interaction, and to ensure both MDR-TB patient and provider are protected from nosocomial transmission of COVID-19. And at last, without preparation for this twin pandemic, we risk setting back MDR-TB care years, if not decades. Thank you for your attention. I'm ready for any question if there is.
Thank you, Dr. Nasiri. Thank you very much for your nice presentation and your data. Do you have any question, participants?
I just want to say that since April or since from the January of the 2020, we published more than 15 paper about the COVID-19 in the most famous journals in the world, and another 15 papers are also under review. One of our papers are currently used by UK government as the guideline for COVID prevention.
Thank you very much for your presentation and your works. Your papers are very good and useful. Thanks.
Dr. Shahcheraghi, Dr. Amini has raised his hand. I give him a microphone.
Yes. Dr. Amini, would you please ask your question?
Yeah, thank you very much, sir, for your nice presentation. I had a question regarding the patients who are suffering from TB. Are there any strong evidence or study that can prove that these patients are basically good candidate or prone to the infection with COVID-19? That means we can consider that as a predisposing factor for COVID-19 infection or no? Or there is no evidence as such? Thank you very much.
Thank you, Dr. Amini, for your good question. As I show in my slides, and as I told, yes, they are prone to the COVID-19 infection, and as just published in a recent publication, it is it should be considered that this patient, I mean, a patient with TB, should be screening for COVID-19 before their treatment or before their hospitalizations, because they are really prone to this infection. And beside this important issue, the interaction between the MDRT medications and COVID-19 medication should also be into consideration.
Dr. Nasir, there is one question in the chat box. Can you see that?
No, unfortunately. In chat box?
Yes, in the chat box. If you want, I can read it.
Yes, I can. I'm just read the question. Does the corticosteroid does differ in the COVID? Thank you for your question, Dr. Eftekhari. You know, in the MDR-TB, in the MDR-TB regimens, we do not have corticosteroid. As I show in the table, in updated WHO guideline, in group A medication, we just have moxifloxacin, levofloxacin, bedaquiline, and linezolid. There is no corticosteroid. But in a COVID-19 patient, yes, they are treated with this kind of medication. And as I just read, and I just indicated in my slide, maybe there was some adverse effect and adverse interaction between corticosteroid and MDR-TB medications, but they are not differ. I hope that I could answer to your question, Dr. Eftekhari.
Dr. Eftekhari, is okay? You get your answer? No question, no? Thank you very much, Dr. Nasiri. Unfortunately, because Dr. Saleh couldn't connect to meeting by Zoom, I will start my speech, and after me, Dr. Solgi will speak.
Hello?
Hello? Dr. Solgi, you will speak this time or after me? It depends on you. Dr. Solgi?
Excuse me, please wait.
Do you have my sound?
Dr. Shahcheraghi, we can see your desktop. If you want, you can start your presentation.
Dr. Solgi is trying to connect. I don't know.
We can hear Dr. Solgi.
Hello?
Hello, Dr. Solgi. Can you hear us?
How are you?
Dr. Solgi, Dr. Shahcheraghi asked you if you wanted to present or you will start as next speaker.
Okay. Hello everyone. Welcome everyone. I am Hamid Solgi, PhD in medical bacteriology from Isfahan Medical University. Science. My lecture, my lecture title is Infection Prevention and Countermeasure to Reduce Colonization and Infection of intensive care unit acquired paraffin-resistant Acinetobacter and Klebsiella, one of the major challenges in healthcare settings.
Sorry, Dr. Solgi, can you make it full screen?
Okay. The important definition are infection, colonization, CRKP, CRAD, and IPC. In infection, germ or antibody and make you sick and is associated with the appearance of clinical signs. In colonization, unlike infection, the clinical signs don't appear. CRKP is a carbapenem-resistant Klebsiella pneumoniae, CRAD carbapenem-resistant Acinetobacter baumannii, IPC infection, prevention, and control. You know that in recent years, the emergence and the spread of carbapenem-resistant organisms is a major healthcare setting. Clinical infections, especially UTI, sepsis, and ventilator-associated pneumonia caused by this organism are associated with high mortality due to limited treatment option. This infection increases the length of hospital stay. Therefore, it also increases the cost of treatment. Global priority list of antibiotic-resistant bacteria to guide research, discovery, and development that published by WHO in 2017. This list is divided into 3 categories according to the urgency of need for new antibiotics. Priority 1 is gram-negative bacteria that are resistant to carbapenem antibiotics. Priority 2 and priority 3, for example, among the gram-positive organisms, MRSA and VRE are this priority. Various studies around the world show that the cost of CRE infection is higher than the annual cost of many chronic and acute disease. In this study that carried out in United States revealed that the median cost of a single CRE infection can range from 200 from 22,000 to 66,000 for hospitals. This article shows that the prevalence of rates of mortality rate among carbapenem-resistant organisms, for example, the rates of mortality among carbapenem-resistant sensitive among Klebsiella pneumoniae was 25.4%. And the rate of mortality among carbapenem-resistant Klebsiella pneumoniae was increased to 68.4%. The aim of the study was to determine whether IPC intervention can reduce colonization and infection of ICU-acquired carbapenem-resistant organisms in ICU ward in an hospital in Isfahan, Iran. Methods. The present study is divided into time periods: pre-implementation and after implementation of infection control programs. In 22-bed ICU ward in an academic hospital with 220 beds located in Isfahan, Iran. Our results were evaluated at 6 months interval before or pre-implementation IPC program and after implementation IPC program. In before from September 2018 to end of February 2018, and after from March to August 2019, and from September 29 to February 2020. First, existing media assessment were evaluated, and then we linked infection control unit, antimicrobial spreadsheet, and microbiology lab. Core component infection control intervention for control of MDR pathogens in healthcare settings have been shown in the table below. The major variable included active surveillance culture, hands hygiene, isolation room for staff, environmental cleaning, chlorhexidine baths. In our study, we used all of IPC programs with the exception of chlorhexidine baths. For example, about the active surveillance culture, we use a scoring culture to identify patients at the beginning of admission. Or about the hand hygiene, the rate of hand hygiene compliance in pre-implementation was 35%, and after the pre-implementation IPC program, the hand hygiene compliance increased to 38 and 44%. To better implement infection programs, we started with education. The best important training program that were performed in our ICU included preparation booklets, continuous education, intra-ward meeting, face-to-face training, setting rules for learning the bacteria, provided checklist, assessment, feedback to staff. In our hospital, we prepare several booklets for increase staff awareness, and we held training classes for ICUs and ICU staff, and we explained the topics of infection control program and correct microbiological sampling. Setting rules in our ICU for labeling MDR bacteria among infected patients, multiple surveillance at the second time period after implementation IPC control programs. We have identified a bronchoscope as a source of spread carbapenem-resistant Acinetobacter in our ICU. So we modified the disinfectant process of the bronchoscope. One of the important things that we done, it was a training classes for clinicians and medical students in morning meetings. In this table, we have shown the prevalence of carbapenem-resistant Klebsiella pneumonia in ICU1 in prior to one, in first time per implementation IPC program. We collected 50 isolates of CRKP, and after implementation IPC control program, 45 isolates of CRKP were recovered from patient, and third period time, 28 isolates of CRKP collected from patient admitted in ICU. This slide shows the prevalence of carbapenem-resistant in Klebsiella pneumoniae strain that recovered from ICU. In the first time period, overall, 6 isolators of Klebsiella pneumoniae were collected that 50 of them were resistant to carbapenem. And the second period of time, overall, 59 isolators of Klebsiella were recovered. That 45 of them is resistant to carbapenem. And the third time period, from September to February 2019, 66 isolated of Klebsiella pneumoniae isolated from patient, that 28 of isolators were carbapenem resistant. Analysis of Klebsiella pneumoniae strain collected from our hospital revealed that about 70% of CRKP related to infection, and 30% related to colonization. This table shows that the prevalence of carbapenem-resistant Acetobacter in ICU. The first period of time for implementation IPC programs, overall 46 isolated recovered. After implementation IPC programs from March to August 2019, 3 isolators of CRAD were isolated, and the third time from September to February 29, 17 isolators of Acetobacter baumannii were collected. Our results show that we believe that there are no universally usual and successful infection control program in our hospital, especially in our ICU in Iran. This study is one of the first infection prevention control studies that aimed at reducing prevalence of ICU-acquired CRKP and CRD in Islam. Our study showed that the implemented measures were effective in control of colonization and infection XCR pathogen, especially CRKP and CRD in ICU settings. And finally, we suggested that prevention is better than treatment. Thank you for your attention.
Thank you very much, Dr. Solgi, for your nice presentation and your data. Dr. Solgi is young and very active and responsible, and I think you can do many research in this area, because as you told, we have very weak in for prevention control, and we should do many works on this field. Do you have any question? Dr. Amini, would you please? Dr. Feizabadi, would you please ask your question? Dr. Amini, please ask your question. Dr. Amini, raise your hand, but don't ask question. Dr. Feizabadi, would you please ask? After that, Dr. Amini, he will ask.
Thank you very much, Dr. Solgi, for the presentation. I would like to thank you and also other professors present in the webinar, and also all the colleagues and participants. It was very nice talk. What I would like is to recommend you to write this presentation as a full paper and submit it to Iranian Journal of microbiology with more details and data. And also because we need to reorganize our infection control working group in ISM, I would like to invite you to work on this subject, and then we reorganize and re-invite the other people who are interested in this area of study group. Thank you very much. It was very informative presentation.
Thank you very much. Dr. Amini, would you please?
Yes, thank you very much for your presentation. Sir, I had a question. What we have learned during this pandemic is that the secondary infection with the bacteria is almost inevitable in some cases. Do you have any strong evidence that can allow the clinicians to prescribe antibiotic for prophylaxis measure in the beginning of the infection when the patient is diagnosed as a COVID positive? Can we start the prophylaxis with the antibiotic or not? Thank you very much.
Dr. Solgi? Dr. Solgi, where is disconnect? Dr. Solgi, I think Dr. Solgi disconnect, yes? He's not in.
Comment yourself, Dr. Shahcheraghi, about this question.
Please.
Yeah, because
please.
The antibiotic consumption has increased with the pandemic of COVID in our country. There are several national projects submitted to the Ministry of Health and universities to study the current situation with overuse of antibiotics. For some reasons, the physicians prescribe antibiotics, but it is not logic. So the cases of resistance has increased. We have some studies under progress in different universities to understand or estimate the current situation of changes in resistance rate of microorganism to antibiotic with the epidemic of the COVID in our country. I think Professor Giske also gave good presentation on co-infection with bacteria, with Klebsiella, with Acinetobacter, as we notice in these days in our laboratory, they have become highly resistant. So we complained about resistance 2 years ago, but the situation is worse now. If
yes.
you study in these days, you cannot believe that how the resistance increased. This is probably because of overuse of antibiotic for not reasonable evidence. We can make comment, Dr. Shahcheraghi or Dr. Amini yourself, if you give us more information about this.
Dr. Feizabadi, also the Professor Giske said that the crisis of antibiotic resistance in COVID-19 depends on the management of COVID-19 patients and therapy of them, and it depends on regional. Some countries and some hospitals give prescribe antibiotics to every COVID-19 patient, and it's very bad and it's not necessary. But maybe some physicians and some hospitals don't use antibiotic and prescribe antibiotics. I think the usage of antibiotics must be at control for COVID-19.
Maybe Professor Giske can give comments about this too, if he is present at the meeting.
I cannot see Professor Giske, and also
yeah, his picture is here. He's on.
Yes. He's not, I think.
No. Okay.
Do you have any question? We have, after the all speaker, we have a question also section. Thank you very much. I can start my speech. Thank you very much for all speakers. In the name of God, I start my speech about importance of antimicrobial resistance surveillance system, a report from Enterobacterial Resistance Clinical Isolates in Iran. All of us know about that antibiotic resistance is a global threat, and combating for this is need global strategy and global management. Drug-resistant bacteria can infect anyone of any age in any country. They lead to longer hospitalization, stay, higher medical costs, and more preventable deaths. This is why antibiotic resistance is identified by WHO as one of the biggest threats to global health. Scientists warning and about the crisis of antibiotic resistance after COVID-19 pandemic, because in some areas use of antibiotics increased, and they say that maybe the next crisis is the antibiotic resistance crisis. For combat for antimicrobial resistance, we should several strategies to prevent from this resistance. One of the most of them is a surveillance of antimicrobial resistance, awareness of education, infection prevention control, optimal use of antimicrobial medical in medicine and animal health, R&D and investment is very important. Also, surveillance of antimicrobial resistance must be attention. Surveillance is an essential to inform policies to prevent for prevention and control responses. Importantly, it is the current source for assessing the spread of antibiotic resistance and to inform and monitor the impact of local, national strategies and global strategies. On October 2015, WHO launched the Global Antimicrobial Resistance and Use Surveillance System. The first effort was collaborating effort to standardize antimicrobial resistance surveillance. Since its launch, GLAS has expanded in scope, and from 2021, 109 countries enrolled for this program, and Iran also is enrolled in this program of WHO. Based on health and economic impact, WHO initiated the collection of information about several common bacterial pathogens on national surveillance. Acinetobacter, E. coli, Klebsiella pneumoniae, Staph aureus, Streptococcus pneumoniae, non-typhoidal Salmonella, Shigella species, and Neisseria gonorrhoeae. As I told, Iran is enrolled in AMR surveillance system. Iran have collaboration with WHO for several disease surveillance for several diseases such as AMR, TB, HIV, malaria, and the other disease. And one of them is GLAS program for AMR, antimicrobial resistance. This is the report from Iran that sent for the WHO about this common bacteria, such as the results such as antimicrobial susceptibility test, age, sex, infection origin, and data on number of tested patients. As you see, this data should be completed. For example, because of infection origin, we don't have enough information or enough data that we sent for WHO. And for example, this is data from Japan. They completed this program, and the infection origin of these samples are clear. 5 countries in the region piloting the One Health tricycle project for antimicrobial resistance. Iran, Jordan, Morocco, Pakistan, and Sudan involved in this project. And some of these countries, like Pakistan and Jordan, have terminated the project, and with collaboration with WHO, they start the molecular characterization in the form of whole genome sequencing. And Iran and Sudan needed to support by additional essential laboratory supplies for starting this data and experiments. As you know, antimicrobial resistance among members of Enterobacteriaceae family, especially E. coli and Klebsiella pneumonia, has increased dramatically in all over the world and in these days. As WHO priority release, carbapenem resistance Enterobacteriaceae located is the critical priority. Because of the importance of this issue, we gathered the information that and studies have been done on AMR in 4 big cities in Iran between 2010 to 2020. From 4 big cities, from Tehran, Tabriz, Shiraz, and Isfahan, and we used the PubMed and Google Scholar research, and the keywords was Enterobacteriaceae clinical isolates and resistance to cephalosporin, carbapenems, and fluoroquinolones. And the following details were extracted from all screening articles: duration of study, city in which the study was conducted, the total number of isolates, the result of antimicrobial susceptibility test, and the reports of antimicrobial resistance encoding genes. These are the antibiotics that we studied, and overall, about 1,110 reports identified by each step based on our aim. And several records excluded from our study, and finally 78 studies included for analysis. The majority of reported isolates belong to E. coli and Klebsiella pneumoniae. Also Enterobacter sp, Citrobacter proteus, and Serratia also are reported. Finally, the comparison of antimicrobial resistance rates of enterobacterial isolates against cephalosporin, carbapenems, and fluoroquinolones, down duration scale was done. This is the data from Tehran in the 3 scale for resistance to cephalosporin, fluoroquinolone, and carbapenems. As you see, we have the increase of resistance to these 3 clusters in duration of this time. And this is the information from Shiraz. And as you see, the resistance rate is lower than Tehran. And this is the information and from Isfahan. As you see, the percentage of resistance to cephalosporins, fluoroquinolones, and carbapenems during this 3-scale time increased, and we see how high resistance to these clusters in Isfahan. And also, this is the information from a study that took place in Tabriz. The highest resistance rates were reported for cephalosporin in all scales and for all 4 cities. The rate of cephalosporin resistance ranged from 42 to 67% between 2010 to 2013, which increased by approximately 10 to 50% in all cities. And in second scale, it was increased with the exception for Tabriz with 30% increase. The highest resistance against fluoroquinolones were reported from Isfahan with 88%, and in the other cities ranged from 45% to 60% in other cities. And also carbapenem resistance increased gradually from 2010 to 2017 in all cities. In Isfahan, the rate of resistance to carbapenem significantly increased 13% to 62%. And this is very high resistance in this city. This is the comparison between the antibiotic resistance between 2017 to 2020 in 4 cities between these 3 clusters of antibiotics. Overall, the highest resistance rates were reported from Isfahan, and lowest were reported from Shiraz. And it depends on, I think it depends on the management of prescription of antibiotics, the prevention control of hospital committee, and the use of antibiotics in these cities. Also, we extracted the information about the beta-lactamase genes, such as UXA48, NDM1, KPC, and the other of them. The most ESPL gene belongs to CTXM, like the other countries, like the globe. In the all countries, the most ESPL gene belongs to CTXM. As you know, NDM metallobetalux is a very important and if a bacteria have this metallobetalactamase genes, the treatment of this infection is very difficult, and they induce carbapenem resistance in high level. NDM1 metallobetalactamase at the first time detected in Sweden from a 65 years man in 2008, and in Iran in the first NDM1 metallobetalactamase reported from a urine sample of 52 years old man with kidney transplant, and it was isolated and detected from Klebsiella pneumoniae. KPC is the other carbapenemase that is very important, especially in Klebsiella pneumoniae, and at the first time in 2001, it was detected from Klebsiella pneumoniae in Iran. This gene at the first time detected in 2010 12 from a ICU woman patient that from urine sample of this patient, it was detected in Klebsiella pneumoniae that was resistant to colistin, and it was sensitive to tigecycline. The other carbapenemas is OXA48 that widespread worldwide, especially in Mediterranean countries. At the first time, this genes detected in from a Turkish isolate in 2004. After that, in 2014, these genes detected from a Klebsiella pneumonia isolate that was imipenem resistant. Because of the importance of ESBL and carbapenemas producing enterobacterial, we do some research and I talk about two research that done in Iran. One of them done on a clinical isolate and the other done on healthy adults. This is the procedure that we do for part of this research. Collection of bacteria, and after that antimicrobial susceptibility, down molecular characterization, plasmid extraction, and finally plasmid analysis and optical DNA mapping, and in final whole genome sequencing down for some of these isolates. For investigation of the prevalence of ESBL and carbapenemas genes and to explore the distribution of plasmid replicon and molecular epidemiology of CPA isolated in an Iranian hospital, we collected 71 non-repetitive carbapenem resistance enterobacterial clinical isolates. Among all 71 isolates, 47 isolate of Klebsiella pneumoniae, 8 Escherichia coli, 5 Serratia marsens, and 2 Enterobacter cloacae had BELA-NDM1 and BELA-OXA genes together or alone. And as you see, this is a very high percentage for these genes for this resistancy. Also, pulse-field gel electrophoresis analysis revealed that most of the OXA48 and BELA-NDM1 producing Klebsiella pneumoniae strain and also OXA48 producing Serratia marsens were colonial relatedness. But the E. coli isolate was not related and was unrelated. Herein we found major dissemination of BELA-NDM1 and BELA-OXA48 genes, which might be considered endemic in geographical area that they can spread of conjugated plasmids. Importantly, the co-occurrence of NDM1 and OXA48 producing enterobacterials also considerable, since the identification of NDM1 and OXA48 producer in Iran, Lebanon, and Kuwait shows that these carbapenemas is known to be widespread in Indian subcontinent and may also be widespread in the Middle East. We published this data in Frontier in Microbiology, and the other study down on healthy adults. The aim of this study was to investigate the prevalence and antibiotic resistance pattern of ESBL producing and carbapenemas producing Escherichia coli, Ceftazidime avibactam resistance, and ST131 clones isolates in healthy fecal carriers in Tehran, Iran. Of the 550 fecal samples from healthy individuals, 44% were ESB were resistant to third generation of cephalosporins, and 43% of these isolates were ESBL. A total of 540 isolates were identified as CPEC, which resistance to ertapenem, imipenem, or meropenem, and the MIC for these isolates was equal or more than 4 microgram per ml. Among CP isolate, 78% harbored bela-NDM1 gene. And as you see that this percentage is very high for healthy people. Bela-oxa 48 gene was detected in 28% of the CP isolates, and one of the isolates was harbored both bela-NDM5 and bela-oxa genes. 4 CP isolates were found to be resistant to colistin. The MIC of these isolates was 4 microgram per ml, and none of them have MRC genes. A total of 78% of CP isolates were resistant to ceftazidime avibactam, and 21% of isolates were sensitive to ceftazidime avibactam. Overall, our data showed that persistent carriage of EPC, CP, ST101 clones in healthy individuals might increase the risk of carriage in community and hospitals. As you know, ST131 clone is a clone that widespread in worldwide, and the resistance to this clone is very important. It can accept many resistance genes, and the detection of this clone is very important. This research and the other studies have done in Iran shows that presence of carbapenem resistance and carbapenemus producing enterobacterials in clinical and non-clinical clinical isolates that co-harbor beta-lactamase genes, and the other such as NDM1, KPC, IMP, WIMP, and other beta-lactamase such as OXA48 is alarming, because the also percentage of this resistance to this antibiotic is high, and also there is these genes, we detected this gene in these isolates. Importantly, these genes, because these genes are located on the conjugative plasmid, and it's very alarming and important. Also, we published this data in Microbial Resistance Journal, and in conclusion, for improvement of antimicrobial surveillance system, we need more research and more data for understanding the origin of infection. More research concerning the molecular characterization and the molecular epidemiology of resistance isolates, clinical and non-clinical, from all parts and provinces in Iran. Unfortunately, the data from a small city and some cities in Iran about antimicrobial resistance is there is no data, or not enough data there is. And we need more research about this. Studies concerning the colonal relationship of isolate using methods such as pulse field gel electrophoresis, MLST, whole genome sequencing, plasmid analysis, plasmid replicon typing is very important. In general, collection, analysis, and interpretation of data is very important for antimicrobial resistance surveillance system. To achieve this purpose, collaboration of medical microbiologists and clinicians are essential, and we should try to solve this problem in our hospitals and in medical care. In general, our data shows necessary, accurate, and comprehensive multi-central studies from different parts of the country to antimicrobial surveillance system at national level. We have weakness in this field, and we should try to have a mega project that share different parts of the country for to have good data, accurate data, and comprehensive data that we can report this data to Ministry of Health. Thank you very much for your attention. This is a very old mosque in Shiraz. Nasir al-Mulk has a very beautiful mosque. Thank you very much. And if you have any question, I'm ready. Thank you very much.
Dr. Shahcheraghi, we have several questions in the chat box.
Which are the most frequent gram-negative bacteria in co-infection? It's for Dr. Solgi. Which antibiotic can be prescribed empirically in COVID-19 patients with a probable bacterial superinfection? As I know, in the COVID-19 patient, it's not need be prescribed antibiotics. It depends, I think it depends on the situation of a patient, and if we use antibiotic correct antibiotics, maybe we increase the antibiotic resistance and we made more problem for patients. Please, Dr. Amini.
Yeah, thank you very much, ma'am, for your phenomenal presentation. I have a question which you have submitted. You have mentioned that there are some differences in the prevalence of the antibiotic resistance in the different states, like provinces like Shiraz, Tehran, and all that.
Yes.
And that might be due to the way the antibiotic is being prescribed by the clinicians and all. Do you have any scientific evidence for that? Is just simply your assumption or your prediction? Thank you very much.
Thank you very much for your question. It's the difference in antibiotic resistance, the percentage of antibiotic resistance depends on the management of patients and the prescription of antibiotics. For example, in especially maybe from one hospital to the other hospital in one city, the percentage of resistance to antibiotics was different. And we get these results from the study that took place in, for example, in Shiraz or in patient in Shiraz or in Isfahan or in Tehran and Tabriz. It depends, yes, it depends on the how the clinician use and prescribe antibiotics to patients. Do you get your answer?
Thank you, Dr. Shahcheraghi. We have another question. What are the most frequent gram-negative bacteria in COVID-19 infection?
Co-infection. I think this question is belong to Professor Giske. As Professor Giske told, at the first bacteria, it depends on the patient and the geographical area. As Professor Giske, if I don't make mistake, Mycoplasma was the first, and depends the situation, Klebsiella pneumoniae, Staph aureus, and the other bacteria, Acinetobacter, also Acinetobacter, can have infection in COVID-19 patients.
Thank you. And I think the other question is related to Dr. Solgi.
It is about antifungal. It's the speech of Dr. Salehi. Dr. Salehi, unfortunately, couldn't connect by Zoom, and he couldn't speak. This question, I cannot get answer exactly to this question.
Thank you. Dr. Ferizabadi.
Yes. I think Dr. Hakimi will ask questions from Professor Giske, because Professor Giske answered my questions about the prophylaxis. We can read his answer. He is strongly against using antibiotics as a prophylaxis in patients with COVID. So probably if Professor Giske can hear us, please answer my colleagues' questions about usage of antifungal as prophylaxis in patients with COVID-19, because in these days in our country, some antifungal drugs are very expensive and rare, such as amphotericin B or other antimycotic agents. If you can hear us, please type the answer in chat box.
Sorry, Dr. Ferizabadi, Dr. Giske said is in another meeting, and he asked if you can ask your question in the chat box.
Yes.
I don't know if he can hear us or not, but he will read the chat box.
Okay, check.
Yes. There's another question about the antifungal that they write that, do you believe it might lead to an increase in fungal antimicrobial resistance? Yes. If we use antibacterial antifungal overuse, it may be lead to resistance to this antifungal also. Yes.
Dr. Hakimi has raised his hand. I give him a microphone.
Hello, Dr. Hakimi. Would you please ask your question?
Dr. Hakimi, you are on mute. If you want, you can ask your question.
Yes, thank you. Hello, Dr. Shahcheraghi, and thank you for your good presentation. I have a question about the whole genome sequencing in your presentation. I like to know, is it possible to do this part of research in Iran? Because I tried to find a place for doing whole genome sequencing, but none of the companies in Iran can help. But I saw you recommended this technique for a part of evaluation in your presentation. It would be my pleasure if you could guide us.
Thank you very much, Dr. Hakimi, from your question. Yes, we did whole genome sequencing. We have collaborated with Karolinska Institute and also in Australia for whole genome sequencing. Yes, I know because of sanction, it's very difficult this day, especially in 2 last years. It's very difficult, but because we have a common project with Professor Giske, we do whole genome sequencing for some of the resistance isolates. Yes, I know because the transfer of bacteria, transfer of genes to the other countries, it's difficult, and you should get permission from the Ministry of Health, and it takes time, but we should do need this in the information, this data.
And thank you very much for your guide. I have a little contact with Dr. Giske too, and I will try to find a way for his cooperation. Thank you. And I have another question about the efficiency of evaluation, the air token susceptibility in Iran, because I have asked some of the infectious specialists, physicians. They told me ertapenem is a good treatment in different countries. But as I know, and I have asked them, they told it is not a good, it is not a recommended drug in Iran. So I like to know, does it have any importance to evaluate the ertapenem in our evaluation? As I know, it is recommended antibiotics based on the CLSI protocol too.
Yes.
Thank you.
As you know, ertapenem is the more sensitive carbapenem for evaluation of their resistance to carbapenem. And
Yes.
in laboratory, we check the MIC of isolates for carbapenem resistance by ertapenem.
Yes. So it is recommended by you to continue our evaluation.
Yes, yes. If we don't have ertapenem disc, we can or powder, we can use imipenem or meropenem. But the first carbapenem is ertapenem for MIC.
Thank you very much. Thank you.
Thanks. Do you have any question? The other question? Dr. Feizabadi, do you have any comment?
Before ending the session, I would add some words in Persian. If you let us know, then before this, you should say goodbye to all the invited speakers and other people who are not Persian speaking.
Dr. Feizabadi, also I want give some comments about our presentation and our colleague presentation. We can speak in, I think, in Persian, yes? ببینید همکاران
Sorry, Dr. Shahcheraghi, we are live on Facebook, and because of that, if you want, we can stop this live.
Dr. Feizabadi, we can start in Persian or continue with English.
I would like to have some words with my colleagues in Persian, then ending the session.
Yes, it's very good. I think it's better.